Hi students, Mrs. Sims here. I'm sorry I'm not there today, but Cooper woke up not feeling great, so I'm going to take him to the doctor, but I should be back tomorrow. But I didn't want you to get behind on what you're learning, so take out your notes, find the page that says 15.4. That's where we're going to start today. Whenever y'all need to pause the video, feel free to pause if you need to catch up with what I'm writing. But let's go through your notes for 15.4. So 15.4 is all about compound events. So let's define that first. The definition of compound event, just like a compound word is when you put two or more words together, a compound event is just two or more events. Two or more events, like rolling a dice and flipping a coin. That's two events. Or rolling two dice, that's two dice. Or rolling three dice, or flipping three coins. It's just two or more events together is a compound event. And then we're going to look at compound events and we're going to find the sample space. The sample space is just the set of all possible outcomes. The set of all possible outcomes. So it's basically everything that could happen. So like the sample space when you flip a coin is heads or tails. That's the only things that could happen. But when you're talking about compound events, there's often many things that could happen. So to find the sample space, we usually use what's called a tree diagram or an area model. Or you could just make a list of all the things that could possibly happen. But those are the things that we're going to look at today, is how to find the sample space by using these different probability models like tree diagram, area model. So for example, let's say you go to a pizza place and you randomly choose one crust and one style. So you don't care what kind of pizza you get. You just want one crust and one style. So if you look at their menu here, their crust options are thin or stuffed. The style of pizza you can get is either Hawaiian, cheese only, pepperoni, or veggie. So those are the options you're going to just randomly choose. So a way to come up with a list of all the sample space, all the potential outcomes that you could get when you randomly choose your pizza, one way is a tree diagram. So you start with your first option. So our first option is the crust. When you pick the crust, there's two choices, thin or stuffed. So I would write thin, stuffed. Those are the two choices for the crust. Then from there, each crust you can choose Hawaiian, cheese, pepperoni, or veggie. So each option has to have 4 branches coming from it for Hawaiian, cheese, pepperoni, veggie. So if you get thin crust, you could get Hawaiian, thin crust cheese, thin crust pepperoni, thin crust veggie. So there's 4 different types of pizzas that could be created with that thin crust. Same with stuffed crust. If you choose the stuffed crust, you could then choose Hawaiian as your topping, or cheese only, or pepperoni, or veggie. So that is a way, and then I could just make a list when I'm done here. This is basically, I'm going to simplify thin to T, thin crust, Hawaiian. This is thin crust cheese, thin crust pepperoni, thin crust veggie. Same thing here. Stuffed crust, Hawaiian, stuffed with cheese, stuffed with pepperoni, and stuffed veggie. So when you look at this list, there are 1, 2, 3, 4, 5, 6, 7, 8 possible outcomes. So 8 different types of pizzas could be created. So if the question is about probability, like what's the chance you're going to choose thin crust pepperoni? Well, thin crust pepperoni is one of the options out of the 8. So you could say the probability of thin crust pepperoni is 1 out of 8, and that's where you would write that as a fraction. So that is a tree diagram. Tree diagrams are great when you have 2 things, 3 things, when you have more than 2 things, because you could just keep going. Maybe there's another like dessert option. I could get dessert with each of these. Then I could just keep going and draw another branch from each of those options. So tree diagrams are great because you can keep adding branches to show all the different possibilities. Problem is sometimes they get a little bit messy depending on how big they are. But that is one way to find the sample space of a compound event. Let's look at the other way. So this next one says, make an area model to find the total possible number of outcomes of rolling a number cube and flipping a coin. So a number cube is just a dice. Area model, it works much like a multiplication table. If you think about the multiplication tables you used back in, whatever, 3rd or 4th grade, you've got a number at the top and a number on the side, and then the middle is the product of those numbers. It's the same idea. So if you think about what are we doing? Rolling a dice. So on the number cube, think about what the possible outcomes are. When you roll a dice, you could possibly get a 1, a 2, a 3, 4, 5, or 6. So I'm going to put those at the top, and then along the side, I'm going to do the coin. So when you flip a coin, you have 2 possible outcomes, heads or tails. So that creates this rectangle model, this area model. If I then make the rectangle that goes with this, it's going to have 2 rows for heads and tails, and it's going to have 6 columns for the 6 options on a dice. So you can see that 6 options there times 2 options here makes 12 total possibilities. So if I label these, this is getting 1 on a dice, and then heads, 2, 3 heads, 4 heads, 5 heads, 6 heads. And then this represents rolling a 1 and tails, 2 tails, 3 tails, 4 tails, 5 tails, and 6 tails. So there's another way to list all the possible outcomes, so to show the sample space of that experiment. So I could say that there are 12 outcomes. If I wanted the probability of any of those, maybe I'm wondering what the probability of rolling a 4 and it landing on tails is. Well, 4 tails is 1 of the 12 options, so we have a 1/12th chance of selecting the 4 with the tails. So area model's great when there's 2 events. It can only work when there's 2 events, like 2 number cubes, 2 coins, a spinner, and then a dice. But it's got to be 2 things. If you have 3 things, an area model is not going to work, and you would have to use a tree diagram because you can just keep adding branches. So those are the 2 main ways to show sample space: tree diagram, area model. So let's look at the back. When you're talking about how many possible outcomes there are, we use what's called the fundamental counting principle. All it means is if a certain event has m possible outcomes and another event has n possible outcomes, you just multiply them. So for example, if we go back to our dice and our coin, the dice had 6 options, the coin had 2. Which means 6 times 2 makes 12 outcomes. If we go back to our pizza, there were 2 options for crust, and there were 4 options for style. 2 times 4 makes 8 possible outcomes. So if you're just looking for the number of possible outcomes, you can multiply the number of each one by the other. So 2 crusts times 4 styles makes 8 outcomes. So if we look at this example, it says Maggie has 8 shirts, 3 pairs of jeans, 4 pairs of shoes to choose an outfit from. She is just randomly going to select from her closet. So how many different outcomes can she make? So you take the number of outcomes for shirts. She has 8 shirts times the number of jean options she has. She has 3 pairs of jeans times the number of different shoes she has is 4. So 8 times 3 is 24. 24 times 4 is 96. So that gives us 96 different outfits that she could make. So if you have 8, 3, and 4, when you multiply those together, you get 96 different outcomes. Okay? So why don't you take a second, pause the video, use the fundamental counting principle to figure out how many different photo options are there and how many different laptop options are there. So use that same probability fundamental counting principle from above to answer number 1. Go ahead and pause. Okay, hopefully you did number 1. So as far as size, there's 1, 2, 3, 4, 5, 6 sizes that are possible. There are 2 finish options. You could have matte or glossy, and then 1, 2, 3 different edits that are possible. So the fundamental counting principle just says multiply those. 6 size options times 2 finishes, which is 12, and then 12 times 3 edits makes 36 different outcomes. So 36 different possible outcomes. So if I wanted specifically, let's say, what is the probability I'm going to get a 4x6 that's matte and has black and white, is in black and white, well, that's going to be one of the 36 outcomes because that's one option out of the 36. As far as the laptop options here, there are 3 sizes of hard drives available. There are 2 styles of screens, and then 1, 2, 3, 4, 5, 6, 7 colors that you can choose from. So fundamental counting principle says multiply. 3 times 2 is 6. 6 times 7 makes 42 different outcomes, 42 different types of laptops that could be ordered. Okay. For this next one, you're spinning this spinner. That's a 1, I believe. 1, 2, 3, 4, 5. And then you're also flipping a coin. Obviously, you know a coin has heads or tails. So over here, draw the area model for that, and then find the probability of each of these things. So go ahead and pause the video while you answer 2, 3, and 4. Okay, so for this example, here is what your area model should look like. You would have the spinner on one side. It does not matter if you put it on the other side, but spinner on one side, 1, 2, 3, 4, 5 are the possible outcomes there. And then heads and tails for the coin on the other side with the outcomes listed in the table. So because the spinner has 5 options and the coin has 2, that makes 10 possible outcomes there. So the chance of spinning a 2 and flipping tails. So 2 tails is right here. So that is a 1/10 chance. I can get that just by looking at this table. Another way to get that is to think about, okay, on the spinner, there's a 1/5 chance of a 2 because there's 5 sections on that spinner and the 1 is a 2. So I have a 1/5 chance on the spinner times the chance on a coin of getting tails is 1/2. Notice how 1/2 times 1/5 equals 1/10, which we're getting from the area model. So that is another way to do it. Spinning 7 and flipping heads. So 7 and heads, there is no 7 on that spinner, so there is no chance of this happening. 0 is the answer to that one. Number 4, not spinning a 4 and flipping tails. So not a 4, so not those, and flipping tails. So this would be a possibility, this would be a possibility, this would be a possibility, this would be a possibility. So not a 4 and tails has 1, 2, 3, 4 out of the 10 options. Another way I could have gotten that is to look at the spinner, and on the spinner there are 1, 2, 3, 4 numbers out of 5 that are not a 4, times tails on a coin is 1/2. Notice how if I multiply those probabilities together, remember multiply fractions is the best one because you just multiply straight across. 4 times 1 is 4, 5 times 2 is 10, or you can get that from the area model. You have a 4/10 chance. If I want to make that answer a little bit better, I could simplify that. You have a 2/5 chance of that outcome happening. Okay, your practice for today is going to be a worksheet 15.4. You're going to be practicing drawing tree diagrams, drawing area models. Please take the time to do those. Don't just answer the questions without drawing those models. Our learning target today is to learn how to draw the models and read the models. So make sure you're doing that part of your practice, and I will see you tomorrow. Have a great day.